Last time we made the body for the ATC turret for my CNC lathe I'm building now. Today we are going to proceed with it. Actually, we'll be making the internal parts of the mechanism. I prepared some C45 steel. Let's see what we've got. I designed all the stuff already in ZW3D. These are the separated parts of the mechanism. The heart coupling, two parts with teeth to lock the tool head in the angular position. The head is attached to the shaft, which will be rotating and sliding back and forth in the bushing. Next, the axial bearing to bear the spring load. The shaft will be driven through a timing pulley, which will be also sliding along the key. Then goes the spring load assembly, which will pull the shaft back to lock it in the heart coupling. Around 250 kilograms of force. The air cylinder's role is to push the shaft forward and unlock the head in order to rotate and change the tool, and then clamp it back through the springs. Now today we'll get some help from PCBWay.com. They provide services like 3D printing steel and plastic, PCB making, sheet metal manufacturing, and what they sent us today, CNC machined parts. I asked them to make two parts for me. We already worked together in the past and I was really happy of their work. One of the parts is the heart coupling half. Looks really neat. I sent them the 3D step file and made a simple drawing. They took care of the rest. The surface finish is great. We'll test the fit later. And the second part, it will be the shaft. At this point I didn't have the possibility to do it myself, as I don't have the tailstock yet, and I was a bit worried. They took care of it without no problem. The parts look really good, clean finish. Can't wait to put them in our build. Actually, the heart coupling is a couple, two parts together. I thought it will be a nice challenge to make the second part myself, so I made a quick 3D print to check if I designed properly the geometry. Yep, it seems to be fine. Maybe I left a bit too much space between the teeth top surfaces, but clearance is clearance. The geometry seems fine. I guess mine part won't be so shiny, but there is some space for fun. Huge thanks to PCBWay for sending me these parts. If you also have some parts in your project which is difficult to make with your equipment, be sure to check them out. They will probably have the right solution to make it. Let's get back to work. The fun part begins right now. There will be a lot of space to show off my homemade CNC lathe today. Firstly, the rear shaft bushing. If you ask why such big stock for it, honestly, I've got this C45 for cheap, and after some calculations it was cheaper than buying the right size for each part. Some of you might notice there was already a bandsaw cut. I had 3 pieces of similar round material to make all of the parts. In order to make my work efficient and the video some kind of chronological, there might be some unexpected cuts. Hopefully you won't mind that. Those chips. This is what I expected to see 3 years ago when I started this project. The precision seems to be promising too. I'm still learning this machine, so I didn't want to send it in full automatic mode yet. But I was making little G-code programs to take 2 to even 4 passes on each cycle, keeping my eye on what is going on. The external contour is right. Now the inside hole. I made a temporary drill holder and went straight into drilling. I made also a holder for the boring bar. And finally the flange holes on the drill press. There we have it. Let's see if it fits. Yep, it does. Maybe even a bit too easily. Next chunk goes in the chuck. Now the front bushing. Now the stock is prepared for two parts, straight to the bandsaw and back to the lathe. Firstly, the facing. Chamfering, drilling, boring, the axial bearing socket, and the flange holes. And the shaft from PCBWay. That's sweet. This is the axial bearing. It bears axial loads. Let's proceed with digging in material. Almost like titans of CNC, doesn't it? I don't know. I can't hide my excitement when I see such big material remove rate compared to my old lathe. That day, I couldn't keep up with removing the chips from the machine. Check this out. It seems there was a little thingy in the center, and this chunk was really well balanced. Anyways, this is the stock for the second heared coupling part. I decided to make an attachment for my milling machine for round parts. I always needed it, but usually I didn't have the time to make it. Something like this, but on the mill. I 3D printed a template for the holes. Everything had to be done fast and reliable. There we go. The base plate for the truck. The bolt heads will go in the mill table T-slots. Here we go. Bolting it down and ready to go. Material centered, coordinates set, and here the challenge begins. Let's make our second part of the heart coupling, the homemade one. I'm checking with my 3D prototype. Seems right until now. Now the more exciting part, the CNC milling. Firstly, roughing with a 10mm end mill. I generated all the CNC toolpaths in ZW3D, high-speed steel versus C45. Round number 2, the ball end mill. Solid carbide, 6mm. This guy will be finishing the contact surfaces. I use a strategy which should deliver good quality, steep angle walls. That's promising. Now the missing holes on the bottom. Milling done. I gave it a few deburring scratches with the file. Moment of truth. Nice. This was the part of the project I was mostly scared about. Let's finish it. Well, maybe it doesn't look as good as the one from PCBWay, but I made it with much care and love at home. The most important thing is if these two will be working together. It seems they are. I 3D printed out of ABS a prototype of the tool head. We will make it next time out of steel, but this is just for fits. This was one of my first ABS attempts on my Allegro Centauri Carbon. Let's check out if the shaft fits in. Perfect. The tools will fit in there. It's gonna rotate and change for the right cutter. Now the homemade heated flange goes to the tool head. So far so good. Let's make the rest of the mechanism parts. Here is my mini G-code program. It uses the G91 incremental coordinate system. It does 2 passes, each half of a millimeter deep. This machine does a lot of chips. I can't believe it. That's not even aluminum. It's a mass generating machine, I guess. By the way, C45 steel. It machines really smoothly. Really love it. Always nice experience with it. Now the other side. Cutting again. By the way, some of you were asking why I don't use my bandsaw. I had a little issue with it, but it's back alive with us. This one is going to be a spacer for the timing pulley. By mistake, I bought one without the front flange. There goes the drill again. This time we can make use of the round holder again. I'm going to make a clearance cut for the key. And some holes to mount it into the pulley. Kinda ready. It's gonna sit next to the timing pulley on the shaft. Speaking of the timing pulley, it would like to have some tapped holes. I added some counterbores for the bolts when you didn't see it. It was a secret. The pulley is going to be sliding along the keyway, maintaining the ability to transfer torque to the shaft. Next, the spring loading flanges. Again, the mill. We'll be making holes and pockets for the springs, so the springs sit well in place. Also same as with the spacers. I'll make a groove for the key to hide it inside. Yup, that's it. Threads remaining. Now the complementary part for the spring loader. By the way, I was machining here a part which barely fits in the inside jaws. You can see the center is bouncing a bit. But don't worry, I'm going to machine it from two sides, so it won't affect the axis of it. Now the milling. Nothing fancy, same history as always. Here we go. The whole turret won't be ready today, but I can't resist to perform a test assembly. The timing pulley slides well and the here coupling seems to work. Let's take a look at the spring loading thingy. I prepared some die springs, the blue ones. I'll post the link to the springs in the description if someone crazy enough would like to build something like this too. The screws should keep the springs in place. At this point I realized I didn't think it through careful enough. I was about to load the springs with the screws, but I don't know, I can't explain myself. Ah, dang it! I am a blooming lotus flower. Chill. I was about to try to compress it outside the ATC, but I realized the threads in the holes were a bit of angle too. Due to that, the screw was a bit crooked when it was mounted, and the movement wasn't smooth at all. Everything has to be perfect here, or at least adjustable. Check it out. Whoa, this is smooth. I couldn't resist to add the air cylinder, just to check if this has at least some sense. Well, not everything is perfect at this moment, but I like it already. I think I have the solution for the problems, but that's for the next time. Today, I'm too exhausted. Stay tuned and thanks for watching.